In this video, I'm gonna talk about how to use evosuite to generate tests and run tests in the command line. First, there are some prerequisites. The first prerequisite for using evosuite is Java version. This time we're gonna use the evosuite version 1.2.0, which is the newest release. And it only supports Java version up to Java 11. So we have to check our Java version. And we see it's 11. And still, we have to check our Maven version. Since we will use Maven to compile our example project. In evosuite, it supports Maven up to version 3.1. And all your versions are okay, so we check our Maven version. It's 3.9.9, so it should satisfy the requirement. Then we are gonna prepare the class under test. We are gonna download a sample project from the evosuite.org, and the class is a stack data structure implementation. It is very simple. We use wget to download it. HTTP. And the project name is just tutorial. And the class name is stack. It's a zip file, so after downloading it, we are going to extract the archive containing this example by using unzip. And we see this is the main directory, tutorial stack, and we have POM file. And in the main file, we have stack.java. This is what we're going to test. And there's already a test file, which we can still run using evosuite, but it's a bit irrelevant to what we're going to talk today, so we're just going to skip it. Then we change our directory to tutorial stack. And let's first take a look at this. The stack file. Which is in source, main, Java, tutorial, stack. And we can see that it's not long and it's just a stack implementation. After that, we're going to use Maven to compile the project by saying mvn compile. And Maven will produce some output to keep us informed about what it's doing. And at the end, we see build success. So as a result of this compilation, we now have a file called stack.class, and it should be in target. Let's check. Else target classes tutorial. Yeah, and this stack.class, it contains the bytecode of the stack class. And As we said, we're going to use the latest release of evosuite, which is 1.2.0. evosuite consists of two jar files. One is the executable file, and one is runtime test dependency. The executable jar file contains evosuite together with all its dependency libraries. And this is what we need to generate tests. Still, we use wget to download it from GitHub. Oh, and the most used version I think is 1.0.6, which only supports Java version up to 1.8. So still we use 1.2.0 instead. Okay. And tests generated by evosuite use several evosuite-specific dependencies and types of instrumentation, mainly to avoid flaky tests. And these dependencies need to be available on the class path when running the generated test. One option for us is to simply use the executable jar file, as well as for that. But we don't always want the test generation dependencies on the class path. So there is another jar file available. That is the runtime jar, which is smaller and contains fewer dependencies. It's called standalone runtime. And as the name suggests, this jar file is an executable jar file. So we use Java jar to Java jar to try to execute it. And this output is evosuite listing all the possible command line options, because we haven't told evosuite what to do yet. And later on, we're going to use two of them. One is class. It's the target class for test generation. And the next one is project CP. It's a class path of the project under test and all its dependencies. Because when invoking evosuite on our example class, we need to tell evosuite two things. The first one is, what is the class under test? And the second one is, what is the class path, where you can find the bytecode of the class under test and its dependencies. So we just saw the class under test is specified using class argument. And when specifying this, we need to use the fully qualified class name. That is, we need to include the package name as well. And the package name is tutorial. Dot stack. This is a class name. The class path is specified using, we just saw project CP. And the place is target. We just saw that. Target classes. And And we're just gonna wait. If everything worked correctly, the evosuite will produce two files. One is the scaffolding file and the other is the test file. I think it's about to finish. Yes, it's finished. And we use ls, we can see there is a new directory now, which is evosuite tests. Let's let's see that. First, we see that scaffolding file. Tutorial. No. Yes, that's scaffolding. Yeah. So we look into the scaffolding file and we see a lot of things happening in methods annotated with before, after, something like this. And these are JUnit annotations, which ensure that these methods are executed before or after execution of each individual test. The reason for this is that evosuite avoids flaky tests by controlling everything that might be non-deterministic. And this scaffolding ensures that the tests are always executed in the same consistent state. So they should really only fail if they reveal a bug, but not because they're flaky. And the scaffolding is a bit long, but luckily we don't have to look into it. And then we see the test file. First, we can see that it inherits from the scaffolding, so that the setup and put down happens without showing all the overhead to ensure tests are not flaky. And besides inheriting from the scaffolding, we also see some annotation that is specific to evosuite. The test clause declares that it will be executed using evorunner rather than a default JUnit runner. This test runner takes a couple of parameters that tells it which parts of the execution environment are controlled. We can ignore this for now because these parameters are set automatically by evosuite. And the rest of the file are just tests. You can see test 0, test 1, test 5, test, I think they're altogether tests from test 0 to test 5, altogether 6 tests. And they're all annotated with at test because automatically generated tests sometimes do silly things that cause infinite loops. So we always have a timeout and the default value is 4 seconds. Now we can finally run this. First thing to do is still we compile the tests. When compiling the test, the compiler will need to see several things like the root directory, which we need for the tutorial.stat class, and that runtime jar, which is the evosuite runtime library and evosuite tests, which is the root directory where we put the test class files. And there's still things like junit.jar and hamcrestcore.jar because we need junit to execute junit tests. In order to get the junit and hamcrest dependencies, we can use Maven by simply saying Maven dependency copy dependencies. And this will help us download two jar file. One is JUnit, and the other one is Hamcrest Core 1.3. Now we still need to tell the Java compiler where to find all these things. So we have to set the class path environment variable. We just use export class path. First one is that standalone runtime jar. And the second one is this one, JUnit. We can just simply copy it, I think. Oh, sorry. Oh, dependency, I think it's correct. Love to still copy it. Okay. And now we simply compile the test in place using Java-C. On the Java files. And now we see something is outdated, so we use Xlang deprecation. And just copy it. Okay, and it's only one warning. I think it's okay. Should be okay. Let's try to run the test using Java dot JNet dot runner JNet or still tutorial dot stack es test. I think it should be the name. No, test. Test. No. Okay, I think we have the wrong. I think I have the wrong spelling. And I just copied it from my former running window and seems it's correct. So let's repeat it. It's export this class path and use Java C deprecation to compile it, and then use Java awk.unit runner to run this test. And let's see, we had 6 tests altogether from 0 to 5, and they're all correct. So we're done.